once again, in the cat class, you're going to be given everything but the Java files. And understand on the tester class, like I'll show that to you, and I'll come back to this. The tester class has this code, and the idea is your job is to build this cat class that, once again, basically what it stores is the scientific classification for this type of cat, whether it's a tiger or lion or whatever. And so once you build a class, and you give it all the methods and all this, you want to test it. And let me give you some perspective here. So let's say you're building something bigger than just a small lab. You're building a game. And this game has, different objects in it. And so basically each object, you're going to have a class that defines that type of object, okay? And so you have multiple classes. And you're trying to build this game. So what you should do, though, is not like write this whole thing and then try to compile it. No. You should write one class, and then before you start working on the next part of the game, you want to test that class. And by that I mean you check out, see if the constructors behave like they should. Whatever methods you create, you should test those, see if they behave like they should. If there's graphics involved, you try to see if the graphics is working. And then once you know that class is perfect, it works the way you want, then you move on to the next class. So what I'm saying is, here we made a cat class, and then we test the members of the class and the constructors in here. So I made several new cats that test the constructor. I printed the cats, and when I print an object, I call this toString method. So I could just do this as well. But I don't need to type in the word toString, because when you print an object, it automatically calls a toString method. But I'm saying, by printing them, I'm calling the toString method and testing that. And then the get methods that I made, the equals method, I'm testing all those. So that's what it means to test a class, is just try out the methods, see if they do what they're supposed to do, okay? But if it was a project like I'm describing, where it's a big project, once you've tested this tester program that you made, it won't actually be part of the finished product. If it's part of a game, then you end up all these pieces, and you have an actual game file that uses all these different classes. And so the tester is just to do what I said, just test the class, see if it behaves properly and functions properly. Now, look at this. First of all, like I said, if you look at the PDF, then it shows you what method you have to have, and they have to be named exactly as you see in the PDF. Because once again, the way this is set up, all you're given is, well, everything but the source code. You're not given the cat, because that's what you're creating. You're also not given the Java file for the tester. You're given the compiled version. So once again, if I look at the source code, if you were to compile this, then that's what produces this class file, .class. And that's what you actually run. And so you're given that, and the instructions will tell you this. When you're ready, when you're done with your cat class, you put it in there, and you run this batch file, and it'll run the class file, and it'll run this code that I'm showing you, and everywhere we see cat, it's your cat that is going to run on, okay? And so, but I'm saying you can't see this code, because you don't have access to this source code. Which also means, though, you better have these method names in your code, because that's what's in here. Now look at this. Let's go through this real quick. Like I said, create three variable names of the variable names of your choice, but they need to be strings. Make a constructor, and it takes 3 parameters as inputs, and call them what you want. Once again, here the parameter name is different from the instance variable name, so I didn't need this dot. You could put it here always, but you shouldn't put it there unless you need to. One thing that's different about this one versus the other one, and this is not really even typical, is it has a getter method for each variable. I had these 3 variables and have a getter method for each. But there's no setter method. And that's abnormal. But here it kind of makes sense, because once again, if you look at this, like here, for a lion, there's the subfamily name, and there's the genus name, and then there's the common name. Those go together, is what I'm saying, right? And it's not like you're going to change that. And so let's say you're intending to make, like, I don't know, some kind of program that has a catalog of different kinds of cats. You just create one of these. Once you create it, you're not going to change it. And so, in fact, that's the way this is designed. Because the variables are private, like we always make them, and there's no setter methods that allow you to change those variables, once you construct one of these objects, you can't change it. So these CAD objects are actually, they're called immutable objects. Because you can only create them, you give it data at the very beginning, but then you can't ever change it. And like I said, that's not normal. But like the string class is that way. When you make a string object, you can never change what that string object stores. Okay? Now, one more thing real quick. And everyone look up here. One thing I want you to appreciate is that this PDF that shows we call this the public interface of the cat class. So everything that's public that you have access to is described here. That description comes from all the documentation in the Java, in the source code. And there's a way to get all the documentation and format it nicely as a PDF. In fact, when you Google the Java API, that's where all that stuff came from. If you actually look at the source code, all the documentation is in there. And then the PDF, or in that case the HTML, is made from that. So anyway, all right, real quick, I just want to show you the equals method. If you want to compare two cats, it's just what I showed you before. Parameter has to be object. The return type has to be Boolean. The variable name is whatever you want, but otherwise just what I showed you before. You say if it is an instance of the cat class, then make a new cat variable with a typecast in there. And this is also different. You notice it only compares a common name. That's abnormal. Normally your equals method should compare all the variables. But here, once again, if the common names are equal, well then they're going to have the same genus and same subfamily, right? Which is why it was okay in this case to compare just a common name. And so that's your equals method. The toString method, actually let me show you first. When I ran the tester, it produced this output. And remember, I created four different cats. In each one, it shows. Okay, the order is a little different. Oh, I'm sorry. Because they're all cats, it has the family the same for all of them because they're all part of the same family. Here, let me recompile this. I didn't like the output so much. So the same family in all of them, but then each cat stores its own subfamily and its own genus, and then its own common name. But like I said, I had 4 different cat objects, and so you see 4 lines of output. What I'm saying is, if you look at the way I set up the toString method, I broke it up in separate lines just for readability, but actually it all ends up being in one line of output. But this, I guess what I'm saying is, sometimes your line of code is going to be too long to fit all in one line in the program, right? And the person reading the program shouldn't have to scroll over. And so something like this is a good way to format it. You have this part of the string, and then you have a plus sign here, the concatenator. So just move that to the next line. And the white space doesn't matter, so it'll piece it all together and produce the output that I showed you. And so this actually produces just one line of output. That's one way to set it up. The other way is like I have up here. You could create an output variable, a string variable, create it as an empty string, and then everything I had here, I just tack on. I have a plus equals, and so concatenates all this onto it. And so your string has all that. Then next line, it tacks on or concatenates this onto the end of that, and then concatenates more, and then when it's done, it returns that string. They both work the same way. Listen, you don't need a format like this normally, but certainly sometimes your output actually needs to be multi-line output. So I show you this because then, if you wanted to be multi-line output, what you could do is just come over here and at the end of each of these, just put a new line character. And ideally, the way you see it in here is the way you'll see it when it actually gets output. And so I'm saying, if you're going to do multi-line output for your toString, if that's the format you want, then set it up like this in your toString method. Okay? And then, like I said, you can just put a new line at the end of each line, and the way it looks, it gets outputted, looks the way it is in the program. Any questions?
So for the toString method, you have to put the get index?
Good question. It's a good policy. Okay? And listen, let me say again as to why we even set it up this way. Because we could just make these variables public. We could. But it's a bad policy. And it's caused problems in the past. I'm not going to get into that now. But what I'm saying is, if you, as a general practice, like, you could just put the variable names in there. You could, because it's in the same class. You certainly could put the variables. But sometimes you'll make your getter methods return something more than just the value of the variable. And so it's a good policy to put get methods in your toString method. If you just want to put the variable names there, that's fine too. I'm not going to take off. Okay? All right. Once again, good question. Anything else?